If you want to imagine how would your house or your design looks like after the PV system installation, you can use a photoplan tool. The photoplan is only used for visualization. It doesn't affect any calculations or simulations. First thing, you have to import the image of your design containing the area you would like to install your PV system at. It's recommended to have an HD image so you can plan your design effectively and render the image so it becomes closer to reality. You then have to define the geometry of the design or the calculations line. When you click here at the window in the right side, you select the project or the design, two red lines will appear. The two lines should be placed at two vertical edges or perpendicular edges in the structure or in the house, as we can see. These should be including or a part of an area greater than the area of the PVs. When the blue arrows appear, you can drag calculation lines to wherever you want. The red up and down arrow makes you adjust the line's length. I will place the lines at the edges of the home, and the length of the lines will be the length of the edges. So PVSol can raise the image and create a center point or a focus point for the image to accurately calculate dimensions. It's better to zoom in and out using the mouse wheels or here to see the details in a better way. Now the software has created a center point or a center for the image, and you can see that there is no red warning sign shown here as it was shown before. The red exclamation icon appears at the right side window, indicates that there is an error. You can define the shape percentage in the image, or you can set it to depend on the sun position, the shadow areas you create, and the geometry of the shape. A negative percentage indicates that the surface or the geometry or the whole image has a high brightness than the normal it gets from sun rays. 30% indicates that the light brightness is decreased by 30%. It could be simply an adjustment for the image brightness. Add geometry defines the projection of a 3D geometry. It creates a plan for you to work on. Let's say we want to make a plan that includes a rectangular surface. You have three modes: rectangular to define rectangular geometries, also four lines at which you can define the edges that is included in the geometry and also a part of a plan. There are some rules for the modes. Blue lines are perpendicular to the green lines. In the rectangular and four lines mode, blue lines are horizontal lines and the green lines are vertical lines. The horizon mode is used for open spaces. You place the blue lines on an edge and write the length of the edge you obtained by surveying. The green lines are perpendicular or on an edge that is perpendicular to the blue edge. The purple lines should be placed at the horizon in the image. This will create a plan for you with a plan pitch, which is an inclination from horizontal. I will define the edges of this dormer to create a plan that passes through it. I will then define the length of the horizontal lines. Green lines are the vertical lines and should be parallel to each other. Blue is the same also, except for the horizontal lines with the capital letter H. Remember always to enter the correct distances or measurements so you can get accurate measurements and conclusions. I define the edges in the geometry I want to be a part of a plane, and I will write the length of one, and PVSol will conclude the others. If the conclusions is wrong, check the red line's placement as the first step, and the green and blue lines too. You can adjust until you obtain a desired pitch angle, and you can see the plan here. Activate when selected, or if you selected the geometry here, or you can activate or disable the grid view that represents the plan you want. If there are any errors, you can hover here to see what to do. Dependent geometry is a geometry that is based or has a relation to the plane of the geometry I have defined. It could be inclined to it, parallel to it, or just rotated, and other types. Let's define the structure to be inclined to this geometry. We drag the black point to the edge of the structure and drag the plane until it's aligned with this roof edges like this. The rotated type is parallel, but the squares are rotated. You can imagine that the squares are the modules. Actually, modules will take the same alignment of the squares of the grid, so you can rotate modules. The dependent geometry is used for multi-geometric structures. Notice that we work in the Edit tab to get the final results. So, to get the final results or to see the rendering, you can switch to After tab. Before tab, choose only the imported image. Let's continue. I will define a solar area in the plane of the geometry. So now you can see the grid appears when I draw something in the plane. The focus sign is where I started to draw this geometry. Readjusting the focus point will give different allocations for the modules. Warning sign appeared because I didn't define the solar panels types and model. I can only choose different models or colors of the same product I chose before entering the photo plane. Let's select malt gray color. I can adjust rows and column distances and rotate the modules too. Okay, no more warnings. If no panels appear, then surely the dimensions are too small for even a panel or a module to fit in. You can adjust the area of the panels too. Click on the green icon to disable or remove a module from the design, turning it into a red point. The lock icon used to lock an area so it's not adjustable anymore. Here you can see the number of objects. Snap could be used to join the adjacent areas. You can create a 3D roof in the plane you create. Select the plane geometry, then select the roof. Then drag the lines at the edges of the roof. You have to right-click, then select the tiles used to create the roof. If you go to render, you won't see the panels as they are under the roof. Make the roof under the panel and you will see them. You can see the panels of the modules now. BVSOL has made calculations and predictions of all the dimensions. You can measure the dimensions by clicking here, or measure an area or a polyline by clicking here.